Hi guys, welcome to Videos Online. Thanks for watching our videos online. Please have to subscribe. Please do press subscribe button and notification bell. That's our update on this YouTube channel. Today I'm going to be considering the Waec Physics Practical 2023, and this year we are going to be asked question on refraction and reflection under light and optics branch of physics. We know that the practical is based on three branches, which is the mechanics, the light, and the electricity. Basically, I'm going to be considering the light / the optics today, and the question before us is related to the principle of refraction and reflections of light based on the material given to us. And due to this, now we discover that this question or this materials is similar to the question in 2007, that is 2007 Waec Physics Practical. And why is the same thing? Because in this year practical, we are given the reflecting plane mirror, and we are also given the triangular prism, as well as the optical pins and everything that will help you to carry out the refraction and the reflection properties of light ray. And the question before us says that we have a triangular prism here. I believe you can see it, a triangular prism ABC, and then we have line NO. We also have angle theta and emergent ray here. You can see that there's an incident ray that comes on this triangular prism at line AB, and as it reflects, refracted, undergoes refraction. When a light travels from one medium to another, from A, which is in form of angle of incidence, it gets refracted in another medium, which is the glass prism. So it gets refracted, and instead of it coming out as an emergent ray, it was reflected by a reflecting mirror, a reflecting plane mirror, which make it come out at the base of the triangle. So we are carrying out two things here, the refraction and the reflection. So this is all about the refracting and the reflection properties of light. And that's how we're going to use this experiment, using this instruction. Using the above diagram now as a guide, carry out the following experiment. Place the equilateral triangular prism on the drawing paper. Trace the outline ABC of the prism. That's the first instruction. We have to place the triangular prism on the drawing paper. As you can see here, I use a cardboard, placing the A4 paper on the cardboard and on the wood. Now we have to trace out the triangular prism. Remove the triangular prism. Draw line NO, which is a normal. So let's first carry out the two instructions. We have the triangular prism here. So on that day you are going to be given a plywood. So we have to I'm going to draw this. So I'm putting this one tightly on the drawing paper. Everything placed on the drawing board. So you trace the outline. So okay. So the edge of this thing is not that straight, but manage it like that. So you use your ruler to complete this triangle. So this triangle A, B, then C. So now that's that about the tracing out of the triangular prism. So with this now, so we are to draw a normal. NO using what? The protractor. We're going to use the protractor to draw a normal. So let me get my protractor. Okay, here is my protractor here. So I'm going to draw a normal. And how do I draw normal? You mark a point on this side. You mark a point, a convenient point here. So then you place your what? Your protractor on it. Now the line of protractor has a point and also an horizontal line. You make sure that the horizontal line is on this AC. And then your point is also coinciding with what? The point on the what? On the protractor. So we have what? Our point on this and our line AB on the what? On the line of the what? Of semicircle of the protractor. So then we can now measure the normal, which is 0.90 degree. A normal is a line that is perpendicular to line what? AB. So there we can draw it out. This is the point, this is the point, and then you join it together. We extend it a little bit. So this is the normal. Then we are going to draw, we are asked to what? Place the equilateral triangle prism on the drawing paper. Trace the outline ABC of the outline, ABC of the prism. Remove the glass prism. Then draw a line NO. We will draw the line such that it makes an angle what? They say we should draw NO such that it makes an angle I, the angle of incidence. The angle of incidence, we have to draw a line NO, but the first thing is to draw a normal first. Then we are going to draw a line NO such that it make an angle of what? Angle of 25 degrees, which will give us the angle of incidence. So I'm going to use what? This normal to draw an angle of what? Incidence. And how do I do that? So you put back your what? Your protractor. You put back your protractor that is 90 degrees. Notice you put back your protractor, you just measure the normal, which is 90 degrees. We are going to, from that 90 degrees, we measure our 25 degrees. So 90 to 80, we are going to have 10 to 70, you are going to have what? 20 to 65, we are going to have 25. So here, you join this one together. Don't forget we are drawing line ANO. So this and this is going to be connected together with a thick line. Then you extend it with a dashed line. And so on and so forth. You extend it with a dashed line. So this is line N. This is O here. So now this is 25 watts. Incidence is equal to 25 degrees. So you can see here that it is, if you get it, you can see it's passed between 60 and 70. That's 25. So from here now, you place your what? You place back your mirror. You are going to place back your mirror. But now I'm going to turn it around so as to what? To be able to see the reflection. So let me turn it like this. So because what we are going to do now is going to inform with what the refraction of the what light was. But before that, what I'm going to do now is to place your what? Your triangular prism back. So place the what? Replace the prism on its outline. Place the prism on its outline. So that's what you are going to replace the prism on its outline. Then what are we going to ask to do again? Place the prism on the outline, but first of all, you have to fix the 2 points on line NO. fix the what? The 2 pins on line NO. So I will do that now, and then we'll place back the what? The triangular prism. And after we place it back, what do we get? Place the reflecting mirror of the plane mirror in contact with what? Face AC. So let's take it one by one. First of all, let me quickly what? Put the what? The first pin on line what? NO. I don't want to block, that's why I'm putting it in your own direction. So you place this pin on line, this line NO. You place the pin 1 and pin 2 on this line at a reasonable distance. You can see now we have another one. Make sure that these pins are vertically erect, because that's your what? That's your precaution, one of your precautions. So they are vertically what? Erect, and ensure that the pins are vertically erect. So that's that. Then this is R1 and then R2. Then you are going to replace your prism back and check the emergent what? Ray. This line will undergo refraction by checking the what? These 2 pins where there appears to be one on the other what? Side. So I'm placing back my what? My prism now. Then we are asked to place what? The reflecting mirror in contact to what? In contact to AC. I'm going to check it to the other side. I'm just trying to what? Let you see what I'm doing here by not blocking what? The view of the camera. So now I've done that one now. So make sure that everything is done. I'm going to check it the other side to avoid error due to parallax. So I've placed the outline together and I'm playing using the what? The reflecting mirror on the other side. Now let's check what I'm having here. Okay, see, very good. So I'm placing this one now here. So that's that. So here at this point now you will see a point of what? At this place you are going to look at your what? A point of refraction, where the refraction takes place. Where at this place now you must look at where the pins becomes one. These 2 pins will be what? Will becomes one at this end when you look at it from this end. And that's what I'm going to do now. So let me take the what? The optical pins. So where this piece appears to be one, that's where your measurements. Make sure that these pins are vertically erect. They are vertically erect. So it's very, very important for you to get. So now pin 1, pin 2, then where they, look at this, when they, and don't allow your what? Your triangular prism to shake. Look at it very well. It's in good condition there. Where they appear to be one. Somewhere here. So that's my pin 1. Then you place your pin 2 behind it in straight line with this at a reasonable distance. Check whether you are what? So let's say this is it now. Okay, so that's how you do that. That's how you do that. Pin 1, pin 2, everything is fixed. But make sure that everything is vertically erect. Okay. So you can now remove the 2. Everything there. can see there is a point of what? Intersection. So here now, you cannot join it together. Let me put it back to a normal position. And then join it together. These are points. So when I have to extend this line a little bit more further. So you are going to use a long roller. So this is our point here. You join this and this together. Use this thick line to join the word line. Then you join the thick line. Use the thick line. Then when you get inside this one, you use what dash line. So this form so this is that. So this is theta, because this is where the point of T meets. So this angle theta, then this is T, point T. So now make sure you note this word line. It's very, very important. Where this thing meets, and I want to draw it, is when it meets with what this, because that's where your angle theta lies. So if you don't draw it very well, you might not be able to measure the angle point what the angle theta very well. So that's why I'm drawing it very well. So this one now, we have done the what? We have drawn this line. This point R1, R2 where you place your 2 pin. This is R3. Then R4. You can extend this. So now, so having done this now, the next thing now is to what? Is to now draw your normal here at the point of intersection. There's a line that intersects this base here. So you draw your what? Your normal here so as to measure your emergence. This is very, very important. All this line of intersection. So this is where you are going to draw your what? Your normal now. You're going to draw your normal here. So this is the point of intersection here. So you draw your normal here. And how do you draw your normal? You place your mirror, you place your protractor right on this point. So that's why I'm always making points so that you can see the points where I put my protractor. So this is a point here. Mark that point and then you place your protractor on that point like this. Okay. Are we there? So make sure that this line is horizontal to this. Then at the same time, so we have this to this, that are normal. But you don't need to extend the line to that point. Just make sure you the line here, you and this line here. So you draw the normal. So this is the normal. Then this point what? D, and the angle here is what? Angle what? E, which is the emergent. So this is the theta, the emergent what angle. This is the angle where the what? The normal. Which this is the angle where the incident, angle of incident, and then this is where the angle of incident. This point theta is where the angle of incident and this emergent ray meets. So that's why we are asked to measure that theta. So we are going to be measuring I, which is, we are going to be what? The I is given, which is 25 degrees. We are going to be taking the theta, angle theta, then we are going to be taking the what? The emergent angle. So I believe we are following. So with this now, we can now what? Actually what? You can now actually measure the angle of the theta. The angle of the theta. And how do you measure the angle of theta? Look at my protractor here. Look at my protractor here. I'm going to turn the protractor downward and place it on the what? On this mark. On this mark where the two lines are meeting. So I'm placing it now on it where the two lines are meeting together. So, and then my line, the horizontal line of the semicircle of this protractor marks also coincides with this line NO. So this here is it now. So that's what I'm doing here now. Check it very well. You see I'm having 62 here. So I'm having 62. You read from this place 0 is 0. You read from 0 is 0 is 0, 10, 20, 30, 40, and so on and so what? Forth. You read like that. This around what? 62, and thereafter. So you read. The most important thing is to know how to read these values. This is 0, 10, 20, 30, 40, 50. We have 55, and so on and so forth, 60, and so on and so forth. So this is going to give us what? 62 degrees. So the most important is not to what? Measure 62 degrees. Then the other one is what? Angle of emergent ray. You have 62 degrees for theta. Then this one, okay, you can see it's around 30. So you place it here. So we have 0, 10, 20, 30. So this is 31 degree. So that's how you do it for what? For the rest. So you measure it like this. You place it. This one, the measurement is you place it along vertically. Then you start reading from 0 here, 10, 20, 30, and 31 degree, and so on and so forth. If you continue to do this, you see this one will be increasing, this one will be increasing, while this one will be decreasing. So as one is increasing, the other is decreasing. So because of my time, I will just write out the values. So carry out the experiment. This one will be what? Be increasing, this one will be decreasing. So this is just the typical what you are going to carry out on that day. It's how you are going to do it for several values. So that's that. You can see that's just that. It's as simple as that. Place your what? You draw your outline ABC. Then you draw your what? You draw your 90 degree, which is using the protractor. Then after that, you read your what? You draw your angle N, which is angle of incidence. NO, angle of incidence what? NO. So which makes 25 degree. Then you put pin 1, pin 2. Then you replace it with what? Your triangular what? Prism. And because you replace it with your triangular prism, then you look at what? You place your what? Your mirror again in contact with this. Then you look at your R3 and R4. So that's that about the experiment. Now let's look at how the graph will look like. What are we aiming at with the graph? So we'll go into the graph now. I will draw the what? Table of value now. This we are asked to what? We are asked to tabulate table of values. So we have the serial number, the angle of incidence, the theta, and the emergent what? Angle. So 25, we can see we have 62, we have 31, 30, 65, 29, 35, 67, 27, 40, 69, 24. As this one is what? Is increasing down the what? Is increasing. This one is what? Decreasing. You can see increasing, decreasing. If this one is increasing, this one will be what? If this one is decreasing, this one will be what? Increasing. If this one is increasing, this one will be decreasing. So whichever the case, just note down what? Values. So these are the table of values. Now let's go into the what? Plotting of the graph to save our time. Now we were asked to what? We are asked to look at this. The question says we are to what? We are to plot a graph of E on the what? On the vertical axis and theta on the horizontal axis. Plot a graph of E on the vertical axis. So note that E should be on the vertical axis and theta on the horizontal axis. Starting both on 0, 0, determine the slope x of the graph. Then the intercepts on the horizontal axis. Evaluate k equal to x raised to power minus 1 and then state the precautions. The first of all, let's plot the what? The graph. So which says we should what? We should plot E on the vertical axis and theta on the horizontal what? Axis. So the first thing is for us what? Title the what? The graph. Graph of E, which is degree, that's the unit, against theta, which is also in degree. The next thing now is to choose your scale. What should be our scale? The highest value here is 31 and lowest value is 22. So, and I know that here from every two boxes here is 2 centimeters. That is the Waec standard. That big box of Waec standard is 2 centimeters. So that big box of Waec standard is 2 of these. So meaning that what? That big 2 centimeter box of what Waec. Now for 2 centimeters here is going to be what? These 2 smaller boxes. So don't be confused. So for every big boxes of the Waec standard graph is 2 centimeters. So I'm going to use 2 centimeters, which is of 2 boxes here. So this is 1 centimeter plus this one is make 2 centimeters. So this is 2 centimeters. So you have to tell them that 2 centimeters represent 5 units. If your value is going to be what? It's going to, if your highest value is going to be achieved by choosing 5, we tell them 2 centimeters represent 5 degrees. But here it's going to be achievable by 5 what? Degree. So 2 centimeters here represents what? 5 what? Degree. Because my highest value is 81. So I just need like 6 boxes to reach 30, and then 8 boxes to each short to reach the 40 degree. So 2 centimeters represents 5 degree will work for this. So let me see, if I start from here, this is what? 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, and so on and so forth. So I can easily start from what? 0, 0 here. So now let's see for the other one. I can put 0 here for this. Now the other one is 62 and 71. Meaning that the highest value here is 71. So I must choose a scale that will get to 75 or 80 thereof. So now if I choose first centimeter 10, then 2 centimeter 10, 20, 30, and so on and so forth. So this one will be what? This one will be 10, 20, 30, 40, 50. What? 60, 70, what? 80, there we have 90 in case. So now don't forget this is what? Theta on the horizontal axis. And this one is E. This one is going to be 0. That's why starting 0, 0. So this one will be from here to here. It's going to be what? It's going to be 5. Don't forget this is 5. 10, 15, 20, 25, 30, 35, 40, then 45. So whichever the case might be. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45. We have E in degree, while theta is also what? In degree. So that's how what we do that. So from here now, you can now draw our what? Our ruler. So this is my ruler here. Good. So this is my ruler here. Now let's actually draw out of this. So you can adjust this. So to get to 90. So we have what? Our horizontal and vertical axis. This one is going to be what? 5. Now the next thing now is to what? Plot the values on the graph. So I'm not going to go about that. Now the first thing is to know what each box represents. On the horizontal axis we have 10 smaller boxes representing 10. So when you have 10 smaller boxes in between 2 centimeters, so you say 10 divided by 10. So we need that what? Each small box is here mean 1. Now here we have 10 boxes representing 5. So 5 divided by 10 is going to be 0.5. Meaning that each box here represents 0.5. So 2 box now will be multiplied by 2, which is 1.0. So 2 box here is representing 1, while 1 box here is representing 1. So you have to know it when you are plotting the graph. So the first one here is 31, 62, 31, 62. So this one is 31. So I told you 2 boxes here represent what? 1. So 31 will be this, because this one will be 31, 30.5, 31. So I'm going to trace this one. This is my point. Then you trace it to the what? To the 62. 62 will be here. This line here is 62. So we'll trace it up. 62 against what? 30 what? 31. So we have our point to be what here. So yes. So this one will be here. So now that's that. So the next one, that is 31 against, the next one is what? 29 against 65. 29 against 65. So this is 29. This 30. You take 2 boxes away from 30 to get 29. So this is 29 here. 29 against what? 29 against 65. 29 against 65. 29 against 65. Against 65. This is 65 here. Okay. 29 against 65. So we have. So that's another one. So the next one is what? 27 against what? 67. So 20. This is 26. This is 27. This is 25, 26, 27. So 2 boxes. So this 27 along this side. Against 67. That's 65 here. 66, 67. This is 67 here. So this is 67. That's 67 against what? 20. 67 against 27. So the next one is 24 against 69. 24 against 69. 24 against 69. This is 20. This is 24 here. 2 boxes less than what? Is that 25? So 24 against what? 69. This 69 is 24 against 69 along this place. So this is 24, then what? 60 what? 9. The last one is 22. 22 is 21. This is 22. 21, 2 box, 22. So 22 against what? 71. Against 71. This 70, 71. So along this side. So now let's successfully what? Successfully what? plotted what the values, then let's plot the slope. Don't forget you have to get the horizontal intercept and the vertical intercept, so meaning that it must cross this line. So we have what? Let's take the value. This one takes 3 like that. Even takes 4. But if you want to leave 1 on the top, 1 on the down, and decide to take depending on you want, just make sure that it takes at least 3. At least 3. So and your intercept is also very, very important. Your horizontal intercept is very, very important. So let me adjust this. Okay. So we have 1, at least 3, 1, 2, 3. So now depends on you. You can decide to take this 3, you can decide to take this 3. This, but I just want it to be a little bit slopey. So now this is your intercept here. So we have it at 91, 92, then 91, 92, then 92.5, 92.5 as your intercept. 92.5 as your intercept. Please note that 92.5 as your intercept. So it takes at least 3 points here, 1 on the top, 1 there. So let's plot what the slope. Not to waste much of our time. So I'm plotting the slope now. Okay. So I'm trying to locate my E1 and then E2 as well as theta 1 and theta 1. So now here we are. So we have E2 E1, theta 1, and then what? Theta 2. So how do we go about the slope? So we have S is equal to change in E over change in theta. Is E2 minus E1 over theta 2 minus theta 1. So with this now, I have what? E2 to be what? This is 36, 37, 38, 39. So 39.00 minus what? This one is 678, 8.5. So we have 8.50. 8.5, don't forget this 8.5 degree over. So how is it 8.5? And see it is 8.5. So this one E theta 2 will be what? 70, 80, 81, 83, 84, 84. 0 minus what? Minus 50 what? 5. This is 50, 55 degree. So let me use my calculator, which is what? 39 minus what? 850. 39 minus 8.50. We have 30.50 over 84 minus 55. That is 29. So 30.50 divided by 29. This is going to give you 1.105. 1.05 depending on what you get. So this 1.1051 for your slope. Then your slope inverse. The slope inverse, which is K, you are asked to calculate what? K inverse. So which is K is equal to 1 over S, which is equal to K is equal to 1 over 1051. 1.5051. So what do we get? We have 0.951. And project to 2 days which is what? 0.95. As well as this one to be 1.05. So that's that. There's no unit. This is dimensionless because degree cancels what? Degree. And here is the angle what? The angle 90. So that's how your slope. This one, it takes this point, it takes this point, takes this point, and see, take this point. So that's that. Take this one, take this one, takes and takes one, and then it will leave that one completely. So that's that about today's class. If you have not subscribed, do press the subscribe button and notification bell, and that's our update on this YouTube channel. And lastly, before I go, I'm going to write the unit here. This here, 2 centimeter represent what? 5 what? Degree on E axis. On E axis. So, and 2 centimeter represents what? 10 degree on what? On theta axis, because we are using theta axis. So now 2 centimeter represents 5 degree on E axis, 2 centimeter represents 10 degree on what? Theta axis. So that's that about that. We have come to the end of today's class. Please do well to subscribe and press the notification button. Now see update on this YouTube channel. Don't forget to know that the precautions for this experiment is that I ensure that these optical pins are erect during the experiment, and I avoided error due to parallax when taking my readings on the protractor. So thank you once again. Do well to share this video and like the video. Thank you very much.